Assalamu alaikum, Hajam. I am the student ANAN ALADANI, and today me and my friends are going to talk about FM and AM modulation and demodulation. So first of all, let's start with the amplitude modulation AM. So basically, the amplitude modulation is a technique used to transmit information over a carrier wave by varying its amplitude. For the carrier wave, it is a high-frequency signal that acts as a base for transmitting information. How does amplitude modulation work? First of all, the original signal is superimposed into a high frequency carrier wave. Then the carrier wave's amplitude is varied proportionally to the instantaneous amplitude of the audio signal. Then at the end, the modulated carrier wave is then transmitted over the airwaves.
My name is MOHAMMED HABASHA. Today I'm gonna talk about AMD modulation. We have two types of AMD modulation. The first one is diode-based envelope detector. Its function is the diode acts as a rectifier, allowing current to flow only in one direction, effectively chopping off the negative half cycle of the modulated signal. The capacitor role is to smooth out the rectified signal, eliminating the high frequency carrier component and leaving behind the audio signal. And the output of the envelope detector is an approximation of the original audio signal with the DC component representing the carrier frequency. And the second type is the RC filter. Its main function is that the RC filter acts as a low pass filter, effectively attenuating the high frequency components of the signal, such as carrier frequency. The RC filter has a cutoff frequency above which the signal is attenuated. This cutoff frequency is determined by the values of the resistor and the capacitor. And finally, the RC filter improves the quality of the recovered audio signal by reducing noise and distortion introduced by the diode rectifier. And now I'm gonna use LT-Spice to simulate the modulation and demodulation. First, on the left side we have the VN, the sine signal, and here we have the modulator, which gonna add the VN, the input signal to the carrier signal, And on the right side, we have the diode-based RF filter. So I'm gonna click run here. Okay. First of all, we have the VN signal, and after it's multiplied by the carrier signal, it's gonna look something like this. It has an upper and lower part. I'm gonna separate them. This is the V input, and this is the modulated signal. And lastly, we have the demodulated signal using the RF filter, which is gonna look something like this. So here the green part is the V input, the blue one is the V modulated after it's multiplied by the carrier, and the red on top is the demodulated signal, which looks exactly or similar to the original signal. Thank you.
MOHAMMED YAHYA, SALEH SAILAN. Frequency modulation FM. FM is a method of radio communication that uses frequency variation to transmit information. What is FM? Frequency modulation and carrier waves. Principle of FM. Modulation 1 and 2, transmission 3, demodulation. Characteristic of FM. 1. Wide bandwidth, frequency division. 3. Constant amplitude. Advantage of FM: high fidelity audio, improved noise immunity, wide cover. Disadvantage of FM: limited range, limited light use, less efficient for data. Bandwidth consideration in FM: 1. Frequency elevation, bandwidth requirement, spectrum management. Noise reduction in FM: limiter, noise filtering. Application of FM: 1. Radio broadcasting, 2. wireless communication, temerity.
My name is Ayham Odeh, and now I'm going to continue with the FM demodulation. FM demodulation with phase locked loop PLL. We have a PLL principle. The PLL technique involves a feedback loop that synchronizes a local oscillator to the incoming FM signal. Frequency tracking. The PLL constantly adjusts the frequency of the local oscillator to match the instantaneous frequency of the FM signal. On the right, we can see the feedback loop for PLL as an FM demodulator. We have the PD, LPF, and VCO. Working principle of PLL, FM demodulator: 1. Frequency comparison, 2. The error signal, and 3. The VCO control. We have on the right you can see the diagram. The frequency comparison starts and sends it to the frequency counters, and this goes back as a feedback loop to the frequency comparison, and it shows us the error signal generation that leads that to the control, and it gives us the output. Now I'm going to show you the LT spice for the simulator. I have a sinusoidal signal for the input. I give it an amplitude of 1 volt and an offset of 1 volt and a 500 frequency. I'm going to run it so the voltage at the input is this one, and the output, let's put it on top. As you can see, as soon as the voltage rises, the modulated signal, its frequency increases, and as the voltage decreases, the frequency of the modulated signal decreases too. Here is the demodulator for FM signal. The green signal is the input and the output is the blue one. As you can see, same thing at high frequency, but here the signal is flipped, the output is flipped. At high frequency it gives us negative value. It's supposed to give us positive value, but here it gave us negative because we have a negative output. And this is all for our presentation, and thank you.